All right, folks. So let's talk about parallel lines and transversals. And there's a lot that goes into this. I'm going to break it down into two parts. So first of all, just a little vocabulary, things that we have to be aware of. Parallel lines, simply lines that do not intersect and are in the same plane. Now, there's a symbol for parallel. So we have to be very comfortable with that symbol. When we say something like M is parallel to L, that means that we have two lines that are parallel to each other. And the way we show that they're parallel in the picture is we put this extra set of arrows on them. All right, so that's there to indicate parallel. So we might put extra arrows. So in that example, we had two lines. That's why they have arrows at both ends. And then the extra arrows indicate parallel. Now, they're in the same plane. As a result, that means parallel lines will always be going in the same direction. And then, of course, when lines are not parallel, they could be intersecting. Lines that are not parallel would be intersecting, but segments that are not parallel might not be. So just to contrast. So we have a couple concepts that we just want to understand that should make sense. And the first one just says, through any point that is not on the line, so that's the left side, I have a point that is not on that line, there's only one line that I can draw parallel to the first line. So I can draw a million different lines through that point, but only one of them, only one of them is going to be parallel to it. And that's all that means. Through any point that is not on a line, exactly one line can be drawn through it that is parallel to the original line. That's all it means. Same thing with perpendicular, and we're going to talk, you guys know what perpendicular means. So while I can draw a million lines through that point, only one of them is going to be perpendicular to the original line. So again, some important concepts. And along with that, we have this term called skew. So skew lines. Skew lines only occur in three-dimensional figures. Skew lines are not parallel, so they're not going in the same direction, but they're also not intersecting because, again, three dimensions. So if we look at this box, all the lines that are in the same color are parallel. So all four black lines are parallel. All four red lines are parallel. All four blue lines are parallel. They're going in the same direction. Whether it's the front of the box or the back of the box doesn't matter. If they're in the same direction, they're parallel. If they're skew, that means they would never touch each other, but they're not parallel either. So think about the line across the back top and the vertical edge in the front. Since one is at the back of the box and one is at the front of the box, they're never going to touch each other, but they're clearly not parallel. So that's what skew means. All right, we can look at another example. We might have the top left edge going front to back, and maybe the vertical edge in the front here going up and down. Those would be skew. And then, of course, two lines that do intersect might be perpendicular because it's a box. It's made up of rectangles. So each corner is a 90-degree angle. So we might be asked to name a few things. So how many planes are shown in this figure? there are five, the top, it's a pentagon, so there's the top and the bottom, and then there's the five rectangles, so there's 7 planes. Parallel planes, well, we've got the top surface and the bottom surface are the only ones that are parallel. So we might say something like plane ABC and plane GHI, the one at the bottom. Remember, we only need 3 non-collinear points to name the plane. Naming parallel lines, we've got a couple different options here. So first of all of our vertical lines are parallel. So AF is parallel to EJ, and that's parallel to DI, and that's segment is parallel to CH and BG. So we're just saying that all of these are parallel. Remember, the symbol means parallel. So we're just saying this one's parallel to this one, parallel to this one, parallel to this one. But we've also got things like segment AE is parallel. So find it, segment AE, and let's just drop right down to the bottom, is parallel to FJ. And we're not going to do them all, but we can see something like segment BC. Segment BC is parallel to, just drop to the bottom of the picture, GH. Skew lines, as we said, skew lines are not parallel, but they also don't intersect. So find 2 lines that are going in different directions, but yet they don't touch each other. So we could use something like GH, the vertical edge, and then a horizontal edge in the back. So we could say something like, for skew lines, we could say AE and CH. There's no symbol. Maybe I'll use IJ and AF. So a second option, we said IJ and AF. There's no symbol for it. Name intersecting lines. Well, if any 2 that touch each other are intersecting. So we could have AE and EJ. AE and EJ, for example. We've done plenty of those. FJ is parallel. Well, coincidentally, we did this one a minute ago, but FJ, find another line that's in the exact same direction, and we can see it right up at the top there, AE. So let's just fill it in, AE, and segment bars. BC is skew. So again, find BC. Always find it. BC. So we're looking for any line. There's several good answers here. Maybe we can go with IJ at the bottom. There are plenty of good answers. And is it possible for planes to be skew? No, since planes go on forever, they're either parallel or they're going to touch. So, no. It's either parallel or they will intersect. The other vocabulary term that we want to introduce here is this thing called a transversal. And a transversal is just a line that intersects 2 or more other lines, all at different points, though. So we can't have like a starburst. There's no transversal in a star. Our transversal intersects two or more other lines. So you can see in our picture here the transversal. And at every intersection, it creates angles. When two lines intersect, we get four angles. So we get those four angles here, but then we get more angles. We get another four angles at the next intersection, and so on. So we want to understand the transversal. And every time that transversal crosses another line, we get more and more angles. Our goal is going to be to connect these angles, to find relationships. But the old stuff does not go away. So even though we have 8 angles in this picture, we still have angles 1 and 4 that are vertical angles. So 1 and 4 are vertical angles. 1 and 2 are still a linear pair. 6 and 8 are a linear pair. 8 and 5 are vertical angles. So the old stuff does not go away. But what we want to start to do is identify how can we connect the information from one part of the picture to the other. And we have to start here. We have to understand these intersections and these transversals. And that picture can get pretty busy, right? We don't want it to get overwhelming, but it can certainly get pretty busy. We want to be able to identify the transversal that connects the intersections. So for example, if we look at angle 1 and 12, angle 1 and angle 12, the line that connects them, that's the transversal. So it's L. This is really important. For angles 10 and 15, find them, 10 and 15. Now, they're in different intersections, so we're looking for the line that connects the intersections. And we can see that it's line B. Notice that for angles 3 and 13, there is no line connecting them. It would be 2 steps. We're looking for a transversal, a line that connects the 2 groups of angles. So even though we have the pair of angles, there is no transversal that connects them. We would have to go over and down, or down then over. All that means is that when we do it, it's a 2-step problem. That's all it means. Doesn't mean it can't be done. It means that it's more than 1 step. So here we're asked to identify the transversal for each pair. Well, let's find them. Angles 4 and 5. Let's find them, 4 and 5. And the line that connects them, line X. How about for 13 and 12? 13 and 2. Well, 13 and 2. Again, the line that connects them. Sorry. The line that connects them is line J. And that's all we're doing in this exercise. 11 and 14. Find them. 11, 14. What's the line connecting them? Line L. So we're just being asked, what is the transversal? What line connects them? For 6 and 8, the line is X. Now look at 1 and 16. 1 and 16. There is no transversal for that. There's no line connecting them. Seven and 4. 7 and 4. 7 and 4 are in the same intersection. In fact, we knew about these. We didn't even need the rest of this picture. Right there. These are vertical angles. There is no transversal. They're in the same intersection. The purpose of the transversal is to connect two different intersections. They're in the same group. These are just vertical angles. We knew about vertical angles before we ever heard the word transversal. So we don't need a transversal for them. Okay. So again, some vocabulary like parallel lines, skew lines, and a transversal line. The transversals line, the purpose is to connect two different intersections. So as the picture gets more complex, we want to know which angles are being connected. What transversal is responsible for connecting them? Because as we move forward, there are certain properties that we're going to apply that are going to allow us to solve some problems that relate these different angles. Okay. All right, we're going to stop there for part 1.